Okay, so that's all. They are the important features of the group 1, group 7, and the group 0 metals. Now look here, why this physical and chemical properties depend upon the outermost electronic configuration. See, during a chemical reaction or during any physical change means which is accompanied by the chemical reaction. It's all they are all involving only the outermost electronic configuration. So during chemical reaction, there is electron transfer or electron gaining or electron sharing. All these things are taking place only in the outermost electronic configuration, whereas the inner shells are always kept intact. There is no much change in the inner shell. Normally people are trying to, there is one more thing called, even you might have not heard of this, there is spectroscopy called Auger electron spectroscopy. People are doing that. They are trying to remove an electron from the inner shell. Actually, if you go to Kalpakkam Atomic Power Station or somewhere, I have once visited there, where there the scientists are trying to remove electrons from the inner core. See, outer core electron removal is very easy, which is called ionization. But removing an electron from the inner core is really difficult. How to strike out one electron from the inner core? But it is being done, and the people are studying materials like this. So reactivity is mainly depending upon the outermost electronic configuration. So inner shells, they do not have any role in deciding the reactivity of the elements. So that is the cause of a periodicity or recurrence. They are having similar outer electronic configuration. Let me go back to the previous slide. Look here, all the alkali metals are having similar outermost electronic configuration. All the halogens have the similar outermost electronic configuration. All the group 0, the noble gases, they have similar outermost electronic configuration. This similarity causes the similarity in properties also. Therefore, the physical and chemical properties depend upon the outermost electronic configuration. So that is the cause of a periodicity. Therefore, when you are arranging the elements in the increasing order of atomic number, when you come back to a particular state, that metal gets a similar electronic configuration. But this repetition has been observed when you move for the first row 2, for the second row 8, for the third row 8, and for the fourth row 18, and for the fifth row 18, and for the number 18. Who is 18? 18, and then number 32, the recurrence takes place. That is why they are called magic numbers. They are called magic numbers. So that is the cause of periodicity. At regular interval, the characteristics are getting repeated. Now, these three important principles you should understand for the filling up of electrons in the orbitals. First one, Aufbau principle. Aufbau principle states that the filling up of electrons in orbitals takes place in the increasing order of energy. So when electrons come into various energy levels, first the lower energy level will be filled. Only when it is complete, the electron will go to the higher energy level, and then only that level is complete. Then the electrons will enter still energy levels of still further energy. So this is Aufbau principle. Aufbau means to build up, to construct. So electron filling up takes place in the increasing order of energy. And the second important principle you should know is Pauli's exclusion principle, which states that no two electrons residing in the same orbital can have all the four quantum numbers the same. See, every electron in an atom can be defined by four quantum numbers, namely principal quantum number, which speaks about the orbit. Second one is azimuthal quantum number, which speaks about the orbital. Third one is the magnetic quantum number, which speaks about the spatial orientation. And the fourth one is a spin quantum number, which speaks about the direction of the spinning of the electron. So these four quantum numbers are given certain numbers. So if you know the four numbers of one electron, then you can locate or you can give an identity to the electron. But what Pauli's exclusion principle states, principle says, no two electrons residing in the same orbital. See, one orbital can have a maximum number of two electrons. No two electrons residing in the same orbital can have all the four quantum numbers the same, which means that every electron in an atom is unique as long as they are inside. But when they come out, you cannot make any identification. All the electrons will be alike. Suppose if a big stream of electron is coming out of an electron gun, you cannot make any distinction among the electrons. This electron has come from 1s, that electron has come from 2s, all that. You cannot make any distinction. But as long as the electron is present in the atomic system, as long as the electron is present in the atomic orbitals, each electron is unique. No two electrons are alike. Every electron is unique with unique numbers. That is the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. At least any one of these four quantum numbers will be different for every electron. Therefore, every electron is unique inside the atom. That is what is the statement of Pauli's exclusion principle. No two electrons can have all the four quantum numbers the same. And also that means that you cannot place one more electron in an orbital. You can never hope to place three electrons in an orbital. What will happen? The third electron will have all the four quantum numbers the same with any one of the previous electrons. Therefore, you cannot locate three electrons in an orbital. Orbitals will have only two electrons, and these two electrons will not have all the four quantum numbers the same. They will have a different, at least one number different. So that is the Pauli's exclusion principle. According to Hund's rule of maximum multiplicity, when a set of electrons enter a set of orbitals of equal energy, the pairing up will start only after all the orbitals have got one electron each. This is something like getting into the bus. Suppose the total bus is empty. If a person is getting into the bus, immediately he will go and be seated in the window side. If another person goes in, he will never go and be seated along with the one person who is already sitting in the chair, in the seat. He will try to find another window side seat. And the third person, that he will find a seat near the window side. Once all the windows are filled, then only the pairing up will start up. Similarly here, when the electrons enter a set of orbitals of equal energy, so orbitals with equal energy are called degenerate orbitals. Degeneracy. See, degeneracy of a p orbital is 3, which means that p orbital has 3 orbitals with equal energy or 3 orientations. The magnetic quantum numbers are different. It is -1, 0, +1 for p orbitals. The orientations, one is oriented towards x axis, another orbital is oriented towards y axis, and another orbital is oriented towards the z-axis, which means that they are mutually perpendicular orientations. Therefore, these orientations are of equal energy. Hence, when a set of electrons enter a set of orbitals of a p, first electron occupies any one of these three orbitals, and the second electron will be parallel to this, occupy the next orbital. Third electron will try to be parallel with the other two electrons and occupy the third orbital, and then the fourth orbital will try to, pair up. So, according to Hund's rule of maximum multiplicity, the pairing up of electrons will start only after all the orbitals have got one electron each. Therefore, filling up of electrons taking place, the energy order of orbitals have to be explained, and various elements are with very different atomic numbers, how the orbitals are getting filled up. If you are able to fill up the electrons in the orbitals in the correct sequence and in the correct order, then you can very easily speak about the various characteristics. Even you can speak about the characteristics which are not found so far. So these are all the secrets behind the periodicity and the electronic configuration. Now look, so this is how the energy difference of orbitals are there. Look here, n is the principal quantum number. For n is 1, only 1s orbital is there. For when n is 2, 2s, 2p orbitals are there. When n is 3, 3s, 3p, 3d orbitals are there. But what happens? The energy of the 3d orbital is higher than that of the 4s orbital. So the 4, for n is equal to 4, the 4s, 4p, 4d splitting up. There is a small overlap. In the overlap, the 3d goes up and 4d comes down. So 4s comes down. So the energy order 4s is lower energy, is of lower energy than the 3d. And if you look into the 5s, who is number 17? Just listen to the class, man. Don't annotate. Don't mark any line over there. Okay. See, when you take the 5s orbital, 5s, 5p, 5d, what happens? The 5s is below 4d, right? But in between 5d and 6s, the 4f comes. See, actually this dotted line has to be drawn in green color. 4f is here. 4f finds its place after 6s. So this is how the orbitals energies are arranged in the increasing order. So look at sir, class lerka sir. So increasing order of orbital is 1s, 2s, 2p, 3s, 3p, 4s, then 3d, then 4p, 5s, 4d, 5p, 6s, then 4f, then 5d, then 6p, then 7s. This is how the orbitals are. Now look here, when the electrons are filled in hydrogen, helium, then comes lithium, then all these things are coming after 3p, after 4s, the d orbital begins. That is why when the d orbital begins, the transition metals are introduced in between the p block and the s block. And when you are going on filling, when it comes to 6s, even after 5d, the 4f orbitals start. Therefore, the 14 elements are introduced in between 6s and 5d. There comes the inner transition metals or the rare earth metals. And then it goes up, and then again 14 elements are introduced in between s and d block, which comes the actinides. So when you fill up the electrons in the increasing order of these orbitals, you can very well construct the periodic table, and you will understand why the transition metals are coming in between s block and p block, and why the inner transition metals are coming in between s block and the d block. And these are all because of the various energy levels and the Aufbau principle. The electrons are filled up in the increasing order of energy. So now we are going to divide the elements into blocks. what is the position of the last electron, or what is the orbital which is occupied by the last electron of the element, that decides the block in which that element is present. If you take S block, the last electron is getting filled in the S orbital. If it is NS1, it is alkali metals. If it is NS2, they are alkaline earth metals. Therefore, these two, the alkali metals and alkaline earth metals, form the S block. And if the last electron is getting filled in the p orbitals 1 to 6, p1, p2, p3, p4, p5, p6. If it is p1, it is a third group, p2 fourth group, p3 fifth group, p4 fifth group, p6 seventh group, or p5 seventh group, and then p6 is the zeroth group, completely filled electronic configuration. Therefore, these all things form the p block. And now what happens? Before P, sometimes D is getting filled. In such situations, D is a penultimate shell. Penultimate shell means it is before the outermost shell. Outermost shell is S, but before S, the D is there. But by energy state, it is much lower than S. Therefore, D is getting filled first, and S is remaining unfilled or partially filled. In such situations, the filling up of electron is taking place in the penultimate shell. Therefore, the last electron is entering into d orbitals. Therefore, the electronic configuration is n-1, d1 to 10, n1 or 2. They are called the transition metals. This is what is continued in the 3D, 4D, and 5D electronic configurations. Now, the F block comes. Even before the d orbital is getting filled, F orbital is getting filled, which is in the anti-penultimate shell. So penultimate shell is before the outermost shell. Anti-penultimate shell is even before the penultimate shell itself. Therefore, F orbital is found even before d orbital. That is why the F block is found between S block and the D block, which is also named inner transition metals. So it is between the S and the transition metals. It is between the alkaline earth metals and the transition metals. Therefore, they are called inner transition metals. This is how the elements in the periodic table are blocked down into several blocks. So with this, we come to the end of today's class, and I think we are on time. With 9:25, I've completed the class on time, and all the best. Let us see tomorrow. I request Aishwarya to post the attendance.
Yes, sir. Sure, sir.
Okay, right. All the best. God bless you.